this section is about 3 set Venn diagrams, and we are going to get there, but we have to work our way up to it a little bit. So before we get there, we kind of have to talk about this, the idea of, well, what if the set that you're supposed to figure out, rather than just having a single union or a single intersection, has multiple? And that's what's going on here, right? I mean, look at these things. There's a bunch of stuff going on. So what you need to do is find the set in parentheses first, and then you can go from there, and it'll kind of reduce down to something that's more manageable. So like it says here, we want to figure out A union B in parentheses intersect C. So like it says in that first bullet point, we should find A union B, find the one that's in parentheses. Okay, well then A union B, if I look at what A and B are up there, it looks like it's everything in A. And then let's see, what else is in B that I didn't already write down? Just the F. So it looks like it's that. And so then we also know what C is. It's right there. I guess I can rewrite it here to say that that's A, D, and G. And then we want the intersection of those two things. So A union B intersect C. So then that's really just the intersection of the set on the left up here and the set on the right. So let's see. I guess you can base off the smaller one just to see what's also in that union over on the left. So A is in both, and then D is in both, and G is only over here. It's not over there. So that's it. So just A and D. All right, so it's like there's an extra step, but when you break it down to individual pieces, none of them turn out to be anything insane. Here in number 2, and I guess also in number 3 because you can see it, there are multiple things that are in parentheses, right? This one's got an intersection and a union. This one's got 2 unions, and we'd have to do those first. So first things first with number 2, figure out A intersect C. All right, well then, based on what A and C are, I don't know if I can get this all up here at once. I think I can. Let's see, so A is that, and then C is that. So A intersect C, let's see, little a is in both, and D is in both, so it looks like that's what that's going to be. So just A and D. And then B union C is the other one that we're going to need. So B union C, so I'll just write out everything that's in B and then add in whatever's in C that I haven't already written in, which I guess would be A and G, since we already got D in there. All right, then we're supposed to get the intersection of these two. All right, so A intersect C intersected with B union C. So I guess we'll just start with the one on the left since that's smaller, and then see if those elements also show up over there. A is here, A is also over there. Okay, so A is part of this. And D is in here, and it's also over here, so D is in there as well. And it's just going to be the set consisting of A and D. We ended up with the same answer that we did in number 1, which is really just a coincidence that it happened to work out like that, but that's okay. Next would be B union C intersect A union B. All right, here I don't think I can keep scrolling back up and back down. I think that would actually make it more confusing to watch. But B union C, based on what's up above, so B is C, D, E, and F, and A is, or C rather, is A, D, and G. So if I write all that out, it would be C, D, E, F, and then, well, actually, I guess I'm just recopying this, right? So, all right. And then A union B. Let's see there, you write out everything in A, so A, B, C, D, E. And then anything else in B that's not going to be in A, which is really just F. All right. And then we want the intersection of those two. All right. Actually, these look like they're pretty close. All right, looks like there's a lot of overlap here. So let's see, C, yeah, that's in both. D, that's in both. E is in both. F is in both. A is in both. G is not, because it's not over here. And so that should take care of it. And if you look at these two, it's like they're the same size, but the one on the left has a G in it and the one on the right has a B in it. So the other 5 elements show up in both. So that's exactly what we end up with here. All right. So when you get expressions like that with a bunch of unions and intersections, there are going to be sets of parentheses in there. So just do what's in the parentheses first. And that way, all of the individual steps will feel like stuff that we've already done. And eventually, you'll put this big elaborate thing together at the end, just kind of going step by step. So I would say, I guess ultimately, what I'm trying to get across here is try not to do the whole thing at once. It's way too much to kind of have stored in your brain, like all these like little pieces here and there. It's easier just to go step by step by step. And I think actually it will be faster, even though it might involve slightly more writing. Next, now we're getting up to the 3 set Venn diagrams. So what I would say to do, and you don't have to do it this way, but this is what I think works the best, is go inside to outside. And what I mean by that is like with a number of intersections. Because if you're starting off with 3 sets, like you got a set A, set B, set C, there's going to be a triple intersection, like elements that are common to A, B, and C. And that'll be right in the middle of the picture, right? It'll be right in the middle of the Venn diagram. And I guess I can go ahead and draw it and show you what I mean. At least just like the general outline of what this picture looks like. So we're going to have our Venn diagram inside the rectangle for the universal set like we always do. But now, this time, we're going to have 3 circles. So circle number 1, circle number 2, and circle number 3. So like here's A, here's B, here's C, and we're inside U. So it looks like that. So the triple intersection is this part that's part of the A circle, part of B, and part of C. So I would say do that first. Then from there you can start doing the double or pairwise intersections. So they're called pairwise intersections because they only involve a pair of sets. So those are the ones where you're just looking at 2 of them at a time. So like A intersect B, or A intersect C, or B intersect C. Right? Those are going to be your pairwise intersections. And then after that, you just say, okay, well, you know, A had these other elements that we haven't written in yet. We got to get them in there, right? So you just add those sorts of things in at the end, the elements that just show up in one set. So for these 3 sets right here, so for that A, that B, and that C, if we were going to make the Venn diagram, the first thing that I'd be looking for is what shows up in all 3 of them. And I guess you can start with the smallest one, the B, and just start checking. So 4, well, that's not an A, so it's not going to be in the triple intersection. 8, that's also an A. Is that in C? Yes, it is. So 8 goes in the triple intersection. 2 doesn't, because 2, it's in A as well, but it's not in C. So the only thing that's in all 3 of them is 8. So I'm just going to put 8 in there. Then other than that, and I guess I can kind of write this off to the side. So what that is A intersect B intersect C. So that's just 8. You could actually write this a different way. The other way of writing this would be maybe like this. So it doesn't matter which pairwise intersection you do first. You just do one of them, and then you intersect that with the third set. So however the parentheses go, as long as it's just you're getting the intersection of all 3, it's always the same. But okay, we got that. Then we want the pairwise intersections. So A intersect B. Let's see. Well, B has 4, 8, and 2. 4 is not here, but 8 and 2 are both over here. So it looks like that's what this is. So this is 8 and 2, which then means that in the picture, A intersect B is this, right? The overlap between A and B. So that 2 needs to be in there, but it doesn't go where the 8 is. It actually goes up here. So that way it's in A and B, but it's not also in C, right? Because 2 is not over here. It shouldn't be in C. Then A intersect C, I guess we can do next. All right, so I guess C is the smaller one. 9 is in both, right? So 9's here and it's over in A. We already know 8's in all 3 of them. 3 is also in A. 7 is not. So 9, 8, and 3. That's what we're going to need here. So we've got 8 in the triple intersection. This part right here is the intersection of A and C, so I need a 9 and a 3 in there. So there's 9 and 3. Then B intersect C. All right, so then just looking at B and then seeing what's also in C. 4 isn't in here. 8 is. We already know that because that's in the triple intersection. And then 2 is not. So it's just 8. And that means that there's nothing that goes in this piece right here. Right? So 8 is in the triple intersection. There's nothing that's in B and C but not in A. So this part can stay empty. And sometimes that happens where you have an empty piece. And we just happen to get that right now. Then filling in the rest of it, you say, well, what's an A that we haven't taken care of yet? So 8, 3, 9, and 2, they're already in there, but we don't have 1. So that actually goes out here. So 1's in A, but it's not in B and it's not in C. So it needs to be in A, but not in any of these overlaps. So it's just out here in this part of A over here. B has 4, 8, and 2. So 8 and 2 are in these overlaps. 4 doesn't show up anywhere else, so that goes out here. And then C has 9, 8, 3, and 7. So 9, 8, and 3 are already taken care of. 7 goes out here because it's in C, but it's not in A or B. So that's what the Venn diagram looks like. All right, so I think that's the best way to do it, is to kind of go inside out, start with the triple intersection, then do the pairwise intersections, and then just kind of add in at the end any numbers that just show up in one of the 3 sets. All right, then we're supposed to figure out a couple of things. We're supposed to figure out A union C intersect B intersect C. And then this thing that looks like a monster, but it's actually not going to be that bad. All right, so trust me, I know it looks like a monster, but you'll see when we do it, it's not that bad. All right, so the first one is that we're supposed to get A union C intersected with B intersect C. Okay, there's a quick way to do this, which is B intersect C is only one thing. We already figured that out, right? It's just 8. So in order to get that one, I'm going to say, well, we already know that B intersect C is the set consisting of just 8. But then 8 is in A union C, because it's in A, it's also in C. So 8 is an element of A union C. And so that's it, right? I mean, then that's going to tell us that A union C intersected with B intersect C. It's the set consisting of just 8. So that one we could do it kind of fast because we already knew what B intersect C was and it just had one element. So then all we have to do, because ultimately we're trying to get an intersection, is to go, okay, well, is 8 also in this other piece? Because knowing that B intersect C just consists of 8, even before you check over here, there are only 2 options. Either this intersection altogether is going to be the set consisting of just 8, or it's an empty set. Right? If 8 was not in A and it was not in C, so if it wasn't in this union, then we would have gotten the empty set here. But it was there, so that's what we ended up with. And you could do this one the long way. You could do it where you figure out what A union C is, which I guess you could also get from the picture. You could say it's 1, 2, 8, 9, 3, and 7. Right? Everything except for that 4, because the 4 is in B only. But everything else is either in A or in C or both. So you could do that and then say, well, it's that set intersected with the set consisting of just 8, and then you get the set consisting of just 8. That would work, and there's nothing wrong with it, but There was a faster way to do it here where we didn't have to write as much. So I figured that might be the way to go. Number 2, or I guess what I'm calling number 2 here, would be this thing up here where we want to get that set and then union with A intersect C. I think here we're going to be better off just getting these individually. So let's see, A union C intersected with B. All right, so things that are in B that are also in either A or C. So that's saying things that are in B that would then be in one of those overlaps, right? Because here's the A circle, here's the C circle. So within B, right, 2, you go, well, that's an A, right? 8 is an A, also in C. So it's just going to be like the only thing you would leave out from B is 4, right? Because that's in B only. It's not also in here. So that's not going to end up being part of the intersection. And this one's just going to be 2 and 8. And again, you could do this the long way. And you say, well, A union C would be 1, 2, 8, 9, 3, and 7. And then B is 4, 8, and 2. And then 8 and 2 show up in both. And so you would end up with that intersection. But we can also use the picture. And since the picture is there, we might as well use it. And then the other thing that we want is A intersect C, right? That's the other part. We already figured out what that is. It's up here. It's 9, 8, and 3. So since we already did the work to get this when we were putting the Venn diagram together, there's no reason to do that work again. And then from here, we can get that intersection. Or it's a union, not an intersection. So let's see. Let me make sure I got enough parentheses here. A union C intersect B. So it's going to be that union with A intersect C. All right, so if it's a union, I can just add in everything from the first one, so 2 and 8, and then anything else in the second one, which I guess would be 9, and then 3. There, done. Right, so it seems like that's going to be way longer because it's this really complicated looking thing that we have to get with the 3 sets of parentheses. But it's actually not that bad. And part of that, I'll freely admit, was that we could recycle a little bit of work here that we already knew what A intersect C was. But that's kind of why I put this in here as a follow-up to the Venn diagram, so we could do that. All right, next. This is what a lot of questions look like on the homework. So where you're given the 3 initial sets, and then you're supposed to pick out the correct Venn diagram. And the way that I think you're supposed to do it is to put the Venn diagram together and then from there just pick out the one that looks right. But realistically, you can do this by process of elimination. So let's see. The triple intersection, if we're actually going to start putting the Venn diagram together. So the triple intersection, because we're going to start working inside out like we have been. So that's going to be A intersect B, then intersect C. And then basically it's saying, well, what's in all 3? And if I go up and look, the only thing that's in all 3, so I guess C is the smallest one, I can do it from there. 2's not in B, so that's not in the triple intersection. Neither is 4, neither is 5. But 9 is in B and 9 is in A, so that's the only thing that's going to be in all 3. So that means the triple intersection is the set consisting of 9. All right, then notice you could eliminate choice C. So I'm just going to put that in here. So we can say that choice C is eliminated, right? Because you've got to have a 9 in the triple intersection, and here the 9's not there. It's in the wrong spot. So C is out, right? So I guess I could say no. All right. Then we can start doing the pairwise intersections. So the pairwise intersections. All right, let's see. We're going to have A intersect B, which if we go up and look, let's see, I guess B is the smaller of the two. 0, that's not an A, so it's not in the intersection. 1's in both, 3's in both. 7 is not an A, and 9's in both. So 1, 3, and 9, it looks like is what we should have. So set consisting of 1, 3, and 9. All right. So we already know C is out, but look at D. 9 is where it's supposed to be, but up here, so this region where just a 3 is, that's the intersection of A and B that's not also part of C, right? Because this football shape right here is the intersection of A and B. So there should be a 1 up here. There isn't. So choice D is out. And if we scroll up, choice A is also out for the same reason, because there needs to be a 1 here. So we already know what the right answer has to be, right? Because we said, well, this doesn't have the 1 where it's supposed to be, it's out. This doesn't have the 1 where it's supposed to be, it's out. So this is actually the right answer. So if you do it by elimination, you can actually do these really fast. But we'll go through and draw the whole thing because I think it's worth it, even though we know what the right answer is now. So we could eliminate stuff. So choices A and D eliminated. But if we were going to go all the way and just do the whole thing, let's see, then we're going to need B intersect C, and we're going to need A intersect C. B intersect C, if you go and look at the sets, it's just 9. Because if you start with C, since that's a smaller one, 2, 4, and 5 are not in B, but 9 is. So it's just the set consisting of 9. And then A intersect C, if you look at those, I guess again starting with C, since that's the small one, 2's not an A, 5's not an A, but 4 and 9 are. So it's the set consisting of 4 and 9. There, that's what I was trying to say. And then if we go ahead and draw it as though it's not up there in choice B already. So just pretending that that doesn't exist. And let's see here. This is big enough. I guess we're going to find out. All right, 9 is in the triple intersection. Then, let's see, 3 and 1 have to be up here. 3 and 1, barely got those in. So this is A as usual, and then this is B, and then C is on the bottom. Let's see, then, other than that, double intersections. Okay, A intersect B, we've got covered. B intersect C just has the 9, so this thing here is empty. And then A intersect C is 4 and 9, which means the 4 has to be over there. All right, and the part of A intersect C that doesn't also overlap with B. Then other than that, let's see, A has 1, 3, 4, 6, 8, and 9. So 6 and 8 haven't shown up yet. We got to put them out here because they only show up in A. B has got 0, 1, 3, 7, and 9. So 0 and 7 haven't shown up yet. They're just in B. And then C is 2, 4, 5, and 9. So 4 and 9 are already in C, but we need 2 and 5 since they only show up in C and don't show up in either of the other two. And what's down here at the bottom, if I scroll back up, it's that, right? It's the exact same thing as B. But for these sorts of questions, you can actually do them by elimination. If you're doing all the steps right, like working inside out, if you kind of do that and keep one eye on your possible choices, then there will be ones that have problems. And you can go, wait a minute, that's not how that's supposed to work. I guess that answer is not the right one. And so you can just start kind of tossing aside some of the possible choices. And in a lot of cases, you'll figure out what the right answer is before you have the entire Venn diagram done. So if you want to do it that way, I mean, I know you're not technically supposed to, but it works. And it's always going to work. It's not like there's some exception where that's going to fail. So if that makes more sense to you to do it by elimination, go for it, I think.